Mathematical reasoning exercises. Hello everyone, welcome to my channel. My name is Rafael. I am an electrical engineer, and in this video I would like to invite you to observe the solution of 15 questions on mathematical reasoning that I selected from several civil service exams. Let's go to the first exercise. Exercise number 1. Tony fills his car with gasoline. His tank holds 14 gallons of gasoline. He pumped 8.37 gallons into the tank. If his car averages 27.6 miles per gallon, how far could he have driven before running out of gasoline had he not stopped to fill up? Okay, my friends, this is the exercise. Let's go to the solution. The exercise says that the capacity of the tank is 14 gallons and that to complete the tank, Tony pumped 8.37 gallons. Alright, and the exercise also said that the car averages 27.6 miles per gallon. This is the information that we need to calculate what the exercise wants. And the exercise wants how far could he have driven before running out of gasoline had he not stopped to fill up. Okay, we need to know how much gasoline there was before he completed the tank. Okay, the capacity of the tank is 14 gallons and he completed it with 8.37 gallons. So before pumping gasoline into the car, there was 5.63 gallons in the tank. Okay? We are going to use the rule of 3 to find the distance. Okay? If the car travels 27.6 miles with 1 gallon, how long would the car travel with 5.63 gallons? This is going to be our x, okay? And multiplying here, we find that the distance is 155 miles. Alright, he could have driven 155 miles if he had not stopped to top up the tank. Okay, my friends, this is the exercise. Let's go to the next. Let's go to exercise number 2. Alright, my friends, let's go to exercise number 2. Exercise number 2 says that Jane pays $132.50 a month in car payments and $675 for rent. She spends an average $512.50 a month for utilities, food, and other necessities. If she has $3,300 in her savings account, how many months of expenses does she have saved? Okay, my friends, this is the exercise. Let's go to the solution. But before going to the solution, let's analyze the data that the exercise provided. The exercise said that Jane spent $132.50 with car payments, and she spent $675 for the rent, and utilities, food, and other necessities. She spent $512.50. Okay, so Jane has monthly expenses amounting to $132.5 plus 675 plus 512.5, and this is equal to 1,320. These are the expenses. This is what Jane has to spend every month, okay? Jane has monthly expenses amounting to 1,320, and the exercise said that she has in her savings account $3,300, okay? Based on this, we can simply divide. We divide 3,300 by her monthly expenses, which is 1,320, and this is equal to 2.5. Okay, and what does it mean? It means that she has 2.5 months of expenses saved in her savings account. Okay, my friends, for example, if she loses her job, if she's fired, at least she has 2.5 months in her savings account to cope for all the expenses, which amount to 1,320. Okay, this is the exercise. Let's go to the next. Let's go to exercise 3. Let's go to exercise 3, my friends. Exercise 3 says Therese pays school taxes at the rate of 63.55 cents per $1,000 of assessed value of his family's house. His family's house has an assessed value of $235,500. What is his school tax bill for the year? Okay, my friends, this is the exercise. Let's go to the solution, but before going to the solution, we have to understand the exercise. Okay, the Therese pays 63.55 cents per $1,000 of assessed value of his family's house. And the assessed value of his family house is that $235,500, okay? And the question is, what is his school tax bill for this year? All right, let's convert this to dollars, okay? It is gonna be 63.55 converted to dollar becomes 0.6355, okay? And how about the house? The house is worth $235,500, and he pays this amount per every $1,000. Okay, so if we divide $235,500 divided by $1,000, Therese is gonna have to pay 235.5 units, okay? Units of this, of the tax. Alright, so multiplying, we find that 235.5 times 0.6355 is equal to 149.66. This is the amount, okay? This is the amount. This is the school tax for the year for Therese. Did you guys understand? It is very easy. It is very easy. he pays this amount per $1,000 of his house assessed value. If his house is 235.5 times this, okay, the house value is 335.5 times more than 1,000, then he's going to have to pay this amount times this, which is per 1,000, and then we find the value of $149.66 of taxes. Okay, my friends, and this is all for exercise number 3. Let's go to exercise number 4. Okay, my friends, let's go to exercise number 4. Exercise number 4 is a very easy one. The exercise says the distance between Earth and Mars is 2.25 times 10 to the 8th kilometers, and the radio waves travels at 3 times 10 to the 5th kilometers per second on average. How many seconds does it take for radio signals to go from Mars to Earth? Okay, my friends, this is the exercise. Let's go to the solution, but before going to the solution, we have to analyze the data that the exercise provided. And the exercise said that the distance between Mars and Earth is this on average. And the exercise also said that the velocity of radio waves is this. Okay, with this information we can calculate the time. The exercise asks us how many seconds does it take for a radio signal to go from Mars to Earth. Okay, that's the question. Let's go to the solution. Observe that D is equal to V times T. Okay, the distance traveled is equal to the velocity times the time it takes. Okay, the traveled distance is equal to the product between the velocity and the time it takes to cross this distance. Okay, then T is equal to D divided by V. All right, and the distance is 2.25 times 10 to the 8th kilometers, and the velocity is 3 times 10 to the 5th kilometers per second, and this gives a value of 750 seconds. Okay, and what is the conclusion that we get? The exercise asked us how many seconds does it take for a radio signal to go from Mars to Earth, and this is the solution. This is the answer. The answer, 750 seconds. Okay, my friends, this is all for exercise number 4. Let's go to exercise number 5 now. Alright, my friends, let's go to exercise number 5. Exercise number 5 says Svetlana bought 4 cans of soup for $1.35 each, a pound of hamburger for $3.29, and a loaf of bread for $2.10. If there is no sales tax on food in her state and she gave a $20 bill, how much change should she receive? Okay, my friends, this is the exercise. Let's go to the solution, but before going to the solution, let's analyze the data that the exercise provided. The exercise said that each can of soup costs $1.35. Okay, and the exercise said that 1 pound of hamburger costs $3.29, and the loaf of bread costs $2.10, and Svetlana paid with a $20 bill. Alright, and the exercise asks us how much change should she receive? Okay, let's go to the solution. One can is 1.35. 4 cans will be 4 times 1.35, and this is equal to 5.40. All right. Four cans of soup cost $5.40. Now let's compute the total expenditure of Svetlana. It's gonna be total spending will be equal to this 4 cans of soup plus the hamburger plus the loaf of bread. And this is equal to $10.69. But she gave a $20 bill to the cashier. What is going to be the change? The change is going to be 20 minus 10.69, and this is equal to... Okay, my friends, let's go to the next exercise. Let's go to exercise number 6, which is a very easy one. Michelle has a $421.55 per month car payment. If she needs to pay a total of $19,500 including interest, how many months from now will she make her last payment? Okay, my friends, this is the exercise. Let's go to the solution. But before going to the solution, we need to analyze the data that the exercise provided. The exercise says that she pays this amount every month, okay? And she needs to pay a total of $19,500. And the exercise wants us to tell when from now, from this month, when from now will she make the last payment. Okay, my friends, this is very simple. We simply divide, okay? We divide the total amount, 19,500, and we divide by the monthly payment, which is $421.55, and this is equal to 46.26. Okay, my friends, and we make this become 47. And what is the conclusion that we get? Consequently, she will make her last payment in the 47th month. Okay, my friends, a very easy exercise, exercise number 6. Let's go to the next. Let's go to exercise number 7 now. Exercise number 7, Marty, a letter carrier, has noticed that the time it takes him to complete his route is proportional to the weight of his mail bag when he leaves the post office. If it takes him 3 hours to deliver 8 pounds of mail, how long does it take him to deliver 10 pounds of mail? Okay, my friends, this is the exercise. Let's go to the solution. Again, before going to the solution, what we need to do, we need to understand the exercise, and the exercise gave us this data, all right, that for Mari to deliver 8 pounds of mail. It takes him 3 hours, and the exercise wants us to calculate how long does it take him to deliver 10 pounds of mail. Alright, we are going to use the rule of 3. It is a simple exercise. 8 pounds, 3 hours. And how about 10 pounds? It's gonna take us X hours, and X is gonna be equal to 10 times 3 divided by 8, and this is equal to 3.75, and converting it to hours and minutes, it is 3 hours and 45 minutes. Okay, my friends, the exercise asks us, how long does it take Mari to deliver 10 pounds of mail? It takes him 3 hours and 45 minutes. Okay, my friends, a very easy exercise. Let's go to the next. Let's go to exercise number 8. Okay, my friends, let's go to exercise number 8. Celia bought 24 bottles of orange juice for her daughter's birthday party for a total of $30. Now the question, what was the unit price of each bottle of juice? Okay, my friends, this is the exercise. Let's go to the solution. But before going to the solution, let's understand the data that the exercise provided. The exercise said that Celia bought 24 bottles of orange juice and she paid $30, and the exercise wants us to tell the price of one bottle of juice. The question was, what was the unit price of each bottle of juice? Okay, we can simply use the rule of 3. If 24 bottles cost $30, one bottle will cost X dollars. Then X is going to be equal to 30 divided by 24, and this is equal to $1.25. Okay, then we have the answer already. Celia spent $1.25 per bottle. Alright, my friends, this is the exercise. Let's go to the next. Let's go to exercise number 9. Exercise number 9 says, dosage information for a drug specifies that 2.5 milliliters should be administered for every 20 kilograms of a patient's mass. How much of the drug should be given to a patient whose mass is 90 kilograms? Okay, my friends, this is the exercise. Let's go to the solution. But before going to the solution, let's analyze the data that the exercise provided. The exercise said that 2.5 milliliters should be administered to a person weighing 20 kilograms, or for every 20 kilograms, better said. How much of the drug should be given to a patient whose mass is 90 kilograms? Okay, my friends, let's go to the solution, and we are going to use the rule of 3 again. 2.5 milliliters for every 20 kilograms, and if the person weighs 90 kilograms, how much of the drug should we give to the person? We can simply do it using the rule of 3, and then we find that 2.5 times 90 divided by 20 is equal to 11.25 milliliters. Okay? If it is 2.5 milliliters for every 20 kilograms, and if the person weighs 90 kilograms, then we should give 11.25 milliliters to this person. Okay, my friends, and this is all for exercise number 9. Let's go to exercise number 10. Exercise number 10 now. The scale on a map of Ohio says that on the map 2 inches equal 35 miles. What is the distance between Cleveland and Cincinnati, which are 14 inches apart on the map? Okay, my friends, this is the exercise. Let's go to the solution. The exercise said that on a map of Ohio, 2 inches is equal to 35 miles, okay? And the exercise wants us to calculate the distance in miles, provided that the distance between Cleveland and Cincinnati on the map is 14 inches. Okay, my friends, this is the exercise. Let's solve it. We are going to use the rule of 3 again. Okay? 35 miles on the map corresponds to 2 inches. Okay? X miles will correspond to 14 inches. This is what we wish, okay? The exercise gave us this, this, and this. The exercise said that 2 inches on this map of Ohio is equivalent to 35 miles. 14 inches corresponds to, let's calculate it. X is going to be equal to 35 times 14 divided by 2. And this is equal to 245 miles. Alright? Thus the distance, the real distance in the real world, not on the map, in the real world, the distance between the two cities, Cleveland and Cincinnati, is 245 miles. Alright, my friends, this is all for exercise number 10. Let's go to exercise number 11. Exercise number 11 now. A bookstore is having a sale offering a discount on all books in the store. A book with a regular price of $12.95 is on sale for $7.77. Now the question, at the same discount rate, what is the selling price of a book with a regular price of $18.50? Okay, my friends, this is the exercise. Let's go to the solution. The exercise said that a bookstore is having a sale, okay? Is offering a discount on all books in the store. Alright, we are going to base ourselves on this information here to calculate the new price of this book here. Okay, let's go to the solution. Solution. $7.77 is equal to $12.95 minus the discount. Okay? We are taking the discount from the original value to get the sales price. Alright? The new price. The discount is going to be the difference. It's going to be 12.95 minus 7.77, and then we find that the discount is 5.18. Alright, the discount is $5.18 over the original price. Alright, let's calculate the rate. Let's calculate the rate. The rate is equal to 5.18 is equal to X% of the original price, which was 12.95. Continuing, 5.18 is equal to X over 100 times 12.95. And we find an X equal to 40%. Okay? I invite you to calculate this. I'm not going to calculate it all. I'm just showing you the results. Okay? So, what is the discount? The discount is 40% on every book in the store. Okay? Now let's work on this here. Okay? The new price is going to be the original price minus the discount, and the discount is at a rate of 40%. 40% over the original price. And this is equal to 18.50 minus 7.40, and this is equal to 11.10. Okay? So, applying this discount of 40%, we reduce this book from $12.95 to $7.77, and we reduce this book from $18.50% to $11.10. Okay, my friend, this was exercise 11. Let's go to the next. Let's go to exercise 12. Exercise number 12. A game console that lists for $159.95 is on sale at a discount of 15%. If there is a 5.25% sales tax, how much would you pay for the console? Alright, my friends, this is the exercise. Let's go to the solution. The exercise said that this was the original price and that the store is offering this discount. And the exercise also said that there is a sales tax of 5.25%. Okay? Based on this data, we need to calculate the sales price of this console. Alright, the sales price is gonna be the sales price is gonna be the original price minus the discount. Okay? The original price is $159.95, and the discount is 15% on this, okay? Times $159.95. And if we calculate, we find $135.95, okay? However, the sales tax will be charged on the sales price. Then the sales tax is 5.25% based on this $135.95, and this is equal to $7.13. Then if you go to this store, you would pay for this console $135.95, okay, which means the original price minus the discount, which is this price, plus the tax. The tax is 7.13, and this is equal to $143.10. Okay, my friends, one more time. The original price of this equipment, this game console, was this, but the store is offering a 15% discount on the original price. Then we find that the new price is $135.95, but there is a sales tax. Okay? So we have to pay this plus the sales tax, and this is equal to $143.10. And the exercise asked, if there is this sales tax, how much would you pay for the console? We would pay $143.10. Okay, my friends, this is all for exercise number 12. Let's go to exercise number 13. Exercise number 13. Susan unloaded 168 boxes of books from a shipment of 1,052 boxes. The question: what is the percentage of the whole shipment that is left to be unloaded? Okay, my friends, this is the exercise. Let's go to the solution. But before going to the solution, let's understand the exercise. The exercise said that the shipment had 1,052 boxes, and that Susan unloaded 168 boxes. And the question is, what is the percentage of the whole shipment that is left to be unloaded? Again, we are going to use the rule of 3. 1,052 boxes corresponds to 100%, okay? And 168 corresponds to X%. Alright? From this, we get that X is equal to 168 times 100 divided by 1,052, and this is equal to 16%. Okay? This is the amount that Susan unloaded. Okay? But we do not want to calculate the amount that Susan unloaded. We want to calculate the amount left to be unloaded. Then it is going to be 100% minus 16%, which is equal to 84%. Alright, my friends? Thus, if Susan unloaded 16% of all the boxes, there is still 84% to be unloaded. Okay, my friends? This is all for exercise number 13. Let's go to exercise number 14 now. Exercise 14. Ashley's bike store makes a profit of 17.5% on every sale. If this month's profit is $2,175, how much did the store sell this month? That is, what was the revenue? Okay, my friends, this is the exercise. Let's go to the solution, but before going to the solution, we need to understand the information provided by the exercise. The exercise says that Ashley's bike store makes a profit of 17.5% on every sale, okay? And if the profit this month is 2,175, calculate the revenue. Calculate how much did the store sell this month, okay? Observe that 17.5% is equal to 0.175, all right? So if we divide the profit by this number here, which represents the profit, we get the revenue, we get the amount sold, which is equal to 12,428.57. Okay? All right? Because this multiplying this is this, okay? This is the total amount sold, and this is the profit. If I multiply the profit rate with the total sold, I get the profit of the company, the money that stays with her, that she earns for herself, okay? And then if I divide the money that she gets for herself by the profit rate, we get the revenue, the total amount sold. Alright, my friends, and this is all for exercise 14. Let's go to the last exercise. Let's go to exercise 15. Okay, my friends, let's go to the last exercise. Let's go to exercise 15. A fully filled passenger jet airplane weighs 987,000 pounds at takeoff. If it carries 422,000 pounds of fuel, what is the percentage of the airplane's takeoff weight is fuel? Okay, my friends, this is the exercise. Let's go to the solution. The exercise said that at takeoff the airplane weighs this amount, and from this is fuel, all right? And what is the percentage? What is the percentage of this is this? Okay. let's go to the solution to find out. Okay, we are going to use the rule of 3. Okay, 987,000 pounds represents 100% of the weight of the airplane. 422,000 pounds represents X percent of the weight of the airplane. Okay? Then X is going to be equal to 422,000 times 100% divided by 987,000. Okay? And this is equal to 42.7%. And what does it mean? It means that at takeoff, 42.7% of the weight of the aircraft is fuel. Alright, my friends, this is all for exercise 15, and this is all for this video. I hope you enjoyed the video and learned from it. I am a teacher, my friends. If you want to book a lesson with me, use my WhatsApp number, guys. Goodbye!